Okay, that's great.
Yes, my name is Eva Sundin and I have introduced you, so please go ahead, Mr. Klaus Peters, with the presentation. You have 20 minutes and then we have some few minutes for questions, so please.
Okay, so thank you for the introduction and good morning to everybody. I'm sorry that I'm not personally available to attend the conference, and I really wish the conference good success and very fruitful discussions with all of you. And I also like to thank you for the opportunity to speak on the sustainable production business of Texas. My presentation will cover four parts. I will start with the context of the steel industry, shortly explain about assets, before coming to the main part, which is the sustainable steel production, and finalize with some conclusions. The context. So, steel is everywhere, with per capita consumption in the world of 185 kilograms, which is almost the double in Europe. We have a very strong support of the thesis that the existence and the use of steel is linked to the population growth of living and the quality of life. To give some European steel figures, we are almost at the level of 300 million tons production per year, and the steel sector contributes to the European welfare by 350,000 direct jobs. So steel is very important as supporting key enabling technology, and it is well recognized as an advanced steel world in all the European countries. And have a look on the world perspective. So to see in the 90s, we were at the level of 800 million tons world production, and this has up to now almost doubled. And having in mind the amount of European steel production, this is the difference between two lines, and the growth situation in Europe is totally different, it's very stable. So the question is, what is the relevance of being steel production? Obviously, it's more related to quality and value added instead of volume and mass. And the steel sector's business impact, especially in regards to sustainability, is explained on this slide. So the steel industry has to recover its raw materials, which is mainly iron, from natural or anthropogenic sources. And by doing so, it allows to construct and maintain the structure of the world we are living in, and this also plays a decisive role on how to develop the future of our world. And dealing with materials is not the only important aspect. Energy is also very important. Please have in mind that the steel sector has to marshal primary and secondary raw material energy, which is for the integrated steel production unit in the area of 18 gigajoule, as well as logistics. And this is in the area of 2 tons raw material per ton of steel produced. And this has to be done in a very complex way at a global scale. And this is done by something like 2 million people on a worldwide basis, leaving a high GDP footprint, which is much higher than the 2% level, which is related to the steel sector only. And last but not least, the steel sector has to meet not only the economic, but also the environmental targets. And steel has a challenging future ahead. In Europe, I like to say that steel has to stay in Europe, and that means not the material steel, but production of steel. Even if, as I've already shown, the production on a worldwide basis is strongly growing, and not in Europe. Steel is in some kind of a dilemma if you compare the size of the steel companies to the high power of the suppliers and customers. Nevertheless, by the strong alliances of the steel companies, especially the customers, the high technology steel products follow these alliances all over the world and have a great and important impact. The main challenge for us as a steel sector in Europe is to still recover from the crisis of 2008 and especially to accelerate this recovery. And in Europe we are leading in regard to environmental regulation, and this puts challenges to the steel business, showing threats as well as opportunities. And I'd like to encourage all of us to see more of the opportunities in these environmental regulations. Before explaining the sustainable aspects of our sustainable research agenda, I'd like briefly to explain about ESTEP. ESTEP is a European technology platform. It's a free association meeting the criteria set by the European Commission. It has a very broad constituency, which is industry all along the value chain, so also mining and customers are members of ESTEP, research academia and other society stakeholders. It was in 2004 created as one of the first ETPs, and something like almost 200 people are contributing to the work within ESTEP. It's all about, the main document is our research agenda, and it's all about technology and research. We can summarize this nicely by the ESTEP light bulb. So the basis is our strategic research agenda. The work is carried out by the working groups, and here you can see the topics we are dealing with in the ESTEP working groups. And the means of communication are these radars. Most of these is done by road mapping, foresight, and our research agenda, as well as projects, innovation and technology projects. ESTEP is organized, and the main document, the research agenda as well, according to this slide. So on the left side you can see the 7 working groups of ESTEP, which are following these main topics. And of course we are well aware of the European authorities, which have changes in their objectives quite often. So we like to follow real topics by a smart network approach. If we come back to the main part, I'd like to start with life cycle assessment and life cycle thinking. So these are methods which are well established and widely used. Nevertheless, there's ongoing further development necessary, and I'd like to give just 2 examples to strengthen this thesis. So, for instance, if you look at the tailpipe emissions, the legislation is looking at the emissions of the transport sector, not taking into full consideration the production of the material, nor the reuse or recycling of the material. Another example is the threat to come to misleading conclusions due to oversimplification. So, for instance, there's a big difference on the carbon impact if we have steel coming from the classical blast furnace route compared to steel coming from the electric arc furnace route. and in many cases there is only some kind of general figure taken into account and no differentiation between DC to look. And there are some other examples. I'm not going into further details, but I really like to say that with this circular economy package from the European Commission, a very good approach is on the table to foster further development of such methodologies, and also the Horizon 2020 framework program very much supports such kind of activities, and the steel sector is very active in participating in such international research projects on this topic. One example to complement life cycle thinking and life cycle assessment are material flow analysis or energy flow analysis, where especially the time aspect and the material status aspect is taken into account, as you can see for the material flow analysis on this slide. And if we go to energy flow analysis, it's much easier to add data, because 2 gigajoule are always 2 gigajoule, you can always add them, whereas 2 tons of sand and 2 tons of steel you cannot add. If we have a look at the energy situation and raw materials supply, the steel sector belongs to the energy-intensive industry, with something like 18% is the second most important energy user in Europe, and this is no new information. And on this slide you can see the progress the steel industry has made in energy and consequently also in CO2 emission savings. These are the red and the blue curves indicated by 100% in the 1960s. The driver for this is, of course, a better economic situation in the companies, and of course also to meet the environmental legislation. We can say that within the steel sector, a continuous improvement of resource and energy efficiency is something we've always been done and will continue to do so. And the recent study by Eurofair Asset makes the foresight that still further optimization is possible, something like 80%, or if you're a little more optimistic, even 10 to 12% are possible. Compared to other industry sectors, for instance, the power sector, makes it clear that the steel sector is in a unique position. So the power sector, for instance, can switch to other resources, to non-carbon resources, by nuclear power or renewable energies. If we have a look, what are the possibilities of the steel sector in regard to carbon-free steel production and contribution to low-carbon industry, the blast furnace will always rely on carbon and coke as input material. Nevertheless, you can see on this slide, since already 2004, the steel sector is committed with high effort on finding solutions to contribute to a low-carbon industry. And this can be done by replacing carbon by other reducing agents, also changing the facilities, or by electrolysis of iron anions, or by using the existing facilities and capturing the carbon dioxide. And then we have two further steps possible. The one is to store the captured carbon dioxide or to use it. And by this example, I'd like to remind all of us that such kind of solutions strongly rely on the political framework we are facing. So some time ago, carbon storage was very much favored from the politicians, and now it's almost impossible to find carbon storage sites. And this also supports a stronger use of carbon usage solutions. The steel sector is, of course, also open for biomass-sourced carbon, and if it's properly generated by renewables, then it's carbon neutral. A very high challenge there is to have feed supply with the high amount we need in our steel sector. And having the future look, we see the situation that the amount of steel used by society will increase considerably, so that we will have such a kind of high amount of steel in use, so that the scrap, which is fed back by electric arc furnace route, will become more and more important in the future and replace blast furnace-based steel. In order to make these solutions happen and economically viable, lots of R&D and innovation topics are laying ahead of us. If we have a look on the importance of steel in a very fast-growing and important market, namely the energy market, we can see that the renewable energy systems as well as the old energy systems all rely on steel as an important supporting material, and especially the new developments in the energy market with wind and solar energy sources show that specific ton per megawatt consumption or supply for steel for such solutions is increasing. And we believe strongly that the importance of steel in the energy market will continue. I already mentioned the circular economy package, and such kind of thinking is not new for us as the steel sector. Due to economic reasons, steel has always been recycled almost independently, and we can easily claim that by mass, steel is the most recycled material in the world, and it's already very close to a circular economy approach. And due to the use of scrap, we can call steel also a permanent material. And the collection and treatment of scrap will show that scrap is becoming more and more an important sector, also in regards to the raw material situation. And will change also the scrap business in regard to sorting and quality of scraps. Again, in order to make such kind of scenario reality, there is a strong demand for new technologies laying ahead of us.
No, Mr. Peters.
And it's not only that we following the approach I was explaining so far, which is look especially inside our sites and facilities, and do optimization within the steel plant. Since decades, we already have extended our approach to look at the value chain, which is especially true for the automotive customers, to name one, and to enjoy further synergies by improving the value chain. And today the challenge is also to look outside, to have a cross-sectorial approach, and if then the circle is even bigger, we are very close to the circular economy approach. And if you look at our asset strategic research agenda, the activities regarding sustainability may be clustered according to this diagram. So let's say in the 90s, the main issue was to have a look on the environment as a group. We have to avoid. Yes?
We have short on time. Can you... 2 minutes. 2 minutes?
Yes. And now it's more about also zero waste as a social innovation. And this translates into these challenges. And to come to the conclusion, I'd like to make two major points. The one is that environmentology have to become into a synergy and good cooperation together to foster this continuous improvement situation. And this is the last slide. So the environmental issues were firmly considered as some kind of necessary boundary conditions, and today we see them as a holistic system where all the various parts interact at a complex level. The future of the steel sector is deeply related to the environmental issue, and the asset research agenda, and especially the working with Corporate and Planet, are addressing these challenges and working on providing solutions. The way to move forward is the holistic, cross-cultural, multi-sectorial approach. And the steel culture has always been addressed to reuse, recycling, energy efficiency. However, we see that the pace of change should accelerate. And last but not least, a comment on the regulatory framework. We like to see there a high continuity and reliability to make it predictable. And the second point is to have a balanced framework, balanced in regards to precise and detailed definitions versus to be open and flexible, to be also applied to new emerging technologies. And we're not asking for any steel subsidies, but for a level playing field. So this was the explanation about sustainable steel production as it is laid out in the asset research agenda. Thank you very much for your attention.